not any different from the flash drives that you guys use, the USB thumb drives, same technology. It is persistent. You can power down the unit and the program is retained. The variables will be gone if you power down the unit, just like, on a regular PC, anything that you don't save, when you power down a system, that's gone as well. Okay? And then it also has a whole bunch of, input-output pins. It can read a particular pin to see whether it is measuring about 5 volts or 0 volts. It can also drive a pin to 5 volts or 0 volts. So it has various capabilities of controlling and sensing input-output stuff. And all you need, as I said, is to give it a 5-volt input, and the thing starts to operate. It consumes 20 milliamps at the most at 5 volts. Now, for those of you who have not taken physics, this is not a whole lot of power. We are talking about 0.1 watts here. Now, how much is 0.1 watts? Well, let's take a look at your typical nickel metal hydride rechargeable batteries, AA sized. Okay. When you look at an AA sized nickel metal hydride battery or cell, it is rated at 2,500 milliamp hours at 1.2 volts. In other words, if you discharge this battery at 2.5 amps, it can sustain that discharge for about an hour before it runs out of energy. So the amount of energy included here is basically 2.5 amp hour at 1.2 volts. Hour is a unit of time. Ampere is a unit of rate, how much charge per second. So if you multiply everything together, that will give you a sense of how much energy is stored here. If you want to see how much a single AA cell can power up something like this, all you have to do is to multiply this whole thing. Okay, let me, 2.5 times 1.2 is approximately what? Is it just 3? 3 is
2.75.
2.75? Okay, still 2.75. And then you divide it by 0.1 watts. So that's an easy division. You get 27.5. But what unit are we talking about here? Hours. So that means one single charged nickel metal hydride cell can power up this processor continuously, running at full speed for 27 hours and a half.
That's 3.
It's
3. It's 3. It's not 25. 25 times 12 is 3.
Oh, it's exactly 3? Yeah. So we're talking about 30 hours here. That's how energy efficient it is. Yep.
Yeah, how can is battery doing 1.2 volts? How did it come up to 5 volts?
You can go through different types of DC to DC converters, and they make ones that are 90% efficient. So that means we are probably getting back to 27 hours or so because of the efficiency loss. But that's still impressive.
Yeah.
If you think about it, you have one single AA rechargeable battery, and you can power up a processor like this for 27 hours straight, one day at least, straight. And we are talking about, okay, but someone can say, but we are talking about some tiny little processor that can really not do much. I can tell you right away.
You can do a lot.
This thing is running at 16 megahertz, which by today's standard is really slow compared to your Pentium processors. But this one has more processing power than, it has easily twice or 3 times the processing power of the original PC-AT. With a 286 processor, okay, this thing has at least 2 to 3 times the processing power of the PC-AT, which could run what type of software back then? Lotus 123, WordPerfect, WordStar. So that's how much processing power we can pack into $11, and with this much of this kind of power efficiency.
And costs about a penny an hour.
Well, less than a penny. Less than a penny if you plug it to the wall to AC. Yeah. Any questions about this little digression? I want to point out the digressions, just to show you guys that there are programming other than just processing data. I mean, there are programming. This is called embedded system programming. And the funny thing is, the thing that I'm passing around, that is actually being phased out right now. That this is the last of the previous generation, and the reason is because we could not find a cheap source of the LCD panels anymore. And that thing also takes like 3 PCBs. It takes a long time to assemble the whole thing. So the new design is one single PCB, and it uses Bluetooth. Now the cool thing about Bluetooth is someone can actually do the configuration and monitor the process from outside of the lab because of the wireless connectivity. And I found a good app on the Android that can basically act as a dumb terminal. So basically, someone can use an Android-based, tablet or a cell phone outside of the lab and hook up to it and say, oh, okay, we are running at, we are almost running out of cigarettes. Someone has to go in and change the cigarettes or add additional cigarettes to it. So that's how, Yep.
Or a gas mask.
Yeah. Well, it depends on whether someone likes to smoke or not. Yes.
How much was the unit cost for the controller and the
The PCB costs more than all the components added together. Yep.
Hey, I know it's like way off topic, but I know there was this car that they made, and it was over the iPhone. Like you can control the car by the iPhone. Is that true?
Yeah, you can do that. One of the
How much
students
processing power did that take?
to control what kind of a car.
I don't know. It was just a car that I was just heard about it. I don't know. It was crazy.
Well, since you guys are talking about a remotely controlled car, have I talked about Google cars in this class? No. Now you guys know about street views, right, from Google Map,
Yeah.
and how do they get all the street views?
They drive a
There's a
vehicle
special
with
kind
a-
of car. It's usually a Prius. I think they have alternative cars as well, but it's usually a Prius with a little pod on the top on the roof, and the pod is basically a camera that can basically shoot pictures all around the car, and it also has a very precise GPS unit, so it can basically upload all the imagery. I don't know whether it uploads right away or it's stored in the car, but basically it stores all the images and basically have every single image geo-tagged, and so this way they can go back to the main processing center, so they can piece all the pictures together in street view. So anyway, if you think about it, it's pretty labor intensive. Okay, somebody has to drive a Prius around all the streets, once in a while. Okay, you can see that Street View does update every year or two, in updates. I can tell because I can see what kind of car is on my driveway, and that usually tells me when it was taken, or whether it has a cover and stuff like that. So anyway, it's a tedious process. Okay, it's very labor intensive, and it can potentially be dangerous as well. And what people have found is Google is not driving, it's not hiring people to drive those cars manually. Many of those Priuses are fully autonomous. There's a person sitting behind the steering wheel, but not doing anything. Okay.
No, it's not.
Well, apparently it is not as dangerous as people think it is. Okay. Now this technology is coming from where? Where do you think this technology is coming from?
United States military.
Yes, but to be more precise, which event basically helped to push this technology out to become available?
I don't remember the name of it, but
It's called the Urban Challenge. Okay, so anyone who's interested should look up Urban Challenge. Okay, just go to Google, look up Urban Challenge. It's a competition organized by the DoD, the Department of Defense, because they have paid these defense contractors billions and billions and billions of dollars for years and years and years, and nothing came out. Okay, they always say, "Oh, we are almost done," and then they will give you these little golf cart devices that can follow a soldier around. That's about it. Okay, after billions and billions and billions of dollars and years and years and years of time. So the DoD finally decided, okay, well, what's a few $1 billion, right? In terms of these tons of billions of dollars already spent. So they organized the Urban Challenge as a competition, and they invite just about anyone in the competition. High schools, defense contractors, universities, and so on and so forth, independent people. You and I, if you want to pick up a project like this, you can do it too. So the urban challenge is a competition. It is a emulated or simulated city urban driving environment, but it's completely enclosed. It's not actually on the street outside. And the challenge is, to get a vehicle from one point to another point of the city as soon as possible, but following all the DMV rules. In other words, the vehicles will have to read stop signs, they have to read the traffic lights, they have to know what happens when you have pedestrians, they have the right of way and so on and so forth. And so they have to follow all these rules and yet be able to get from one point to another point as quickly as possible. The exact rules and how they determine who's the winner, you can find it on the web. Okay, I'm not going to repeat that. So this technology was basically quickly evolving because of the competition. The two universities that were really involved in this type of research, one was Stanford University in Palo Alto, and the other one was MIT. And no, I take it back, it's Carnegie Mellon University, CMU. So these two were butting heads in every single autonomous vehicle competition. And it's always alternating. Stanford would win one, CMU will win the next one, and then Stanford will come back and get the next one. So of the two universities, they leapfrog each other so much that they push the technology all the way to the envelope of what can possibly be done with today's technology. And Google has a very long-term tie with Stanford University. For those of you who know the background of Google, it was started by Stanford people. I'm not sure whether they are professors or just staff hired at Google, but that's how Google got a hand on the autonomous vehicle technology, and they decided to deploy it without letting anyone know. Some motorists, who was driving along with a Prius, on the highway, looked and go, oh, that's a Google car, taking street view and all that stuff. Not very, interesting in its own way, but not like that interesting. And then they found that the person who's sitting in the driver's seat was doing something, wasn't doing driving. So that person took a picture, like a video clip from the cell phone, and that's how people knew, oh, so that's what they have been using. I'm not sure whether it is actually street legal or not. I'm pretty sure the DMV can go after Google or something. But since Google is so big, it can probably just convince the government, it's perfectly safe, don't worry. Yep.
I heard about this, and I heard that it's only been in a couple of accidents, and the majority of those accidents were the other person's fault.
Yeah. Well, these programs, they know about all the DMV rules already, and they even have, accident avoidance logic. In other words, if it knows that it can avoid an accident without breaking, DMV rules, it would actually actively try to avoid an accident. Yep, it's better than most of us when it comes to driving.
Do you know which company's got the big truck?
It's a defense contractor. The big truck belongs to a defense contractor. Basically, it's a cheap way to win the competition with a big truck. But that's not urban challenge. That's the grand challenge. Okay, he's referring to a competition prior to the urban challenge. Now, driving in the city is actually harder than driving in the open desert. Okay, the challenge of driving in the open desert is getting over the obstacles. But you don't have pedestrians, you don't have traffic stop signs, you don't have traffic lights and stuff like that. It's just avoiding running into a rock or a ditch and stuff like that, which is usually pretty easy to do because they have what they call lidars. They're kind of like radars, except they use light instead of radio wave signal to do the same thing. So the defense contractor used one of those